Welcome to the Lowdown on Physics. Today we'll be doing a review of motion under gravity. This is something you would have done in Unit 2 Physics and is the basics for projectile motion in Unit 3. So before we go any further, I just want to run through a couple of key things in solving problems. This pretty much goes for all physics problems that we do. Steps that you need to go through, basically a logical order to solve a problem. First thing you need to do, if you're not given a diagram, is draw a diagram. It often helps make sense of what the problem's asking, and it gives you a direction to go to solve that problem. List all your variables, including the one that you're trying to find. The reason is it helps you pick the formula that you want to use. And what I've found in the past is the students that do this on a regular basis tend to do better than those that don't. Check your units. Once you've listed your variables, make sure you have consistent units or SI units. Using that list, find the equation that you're going to use to solve it, then substitute your variables in and solve for the unknown. So the first thing that I mentioned was that we're going to be looking at projectiles, and this is a review of motion under gravity. So this is basically one-dimensional projectile motion. So what is a projectile? Basically it's any object that you launch into the air. And projectile motion is about the analysis of the motion that occurs. So this is, for example, dropping something from a bridge or a cliff, throwing something out horizontally from a cliff where it's going to sort of follow a half parabola towards the ground, throwing something up into the air that's going to come straight back down, or throwing something in at an angle into the air, so it's going up as well as across. So trajectory of a projectile is a name given for the path that it follows, and Galileo many centuries ago recognized that this shape was a parabola, which I mentioned a second ago. So understanding parabolas means that we can come up with equations and ways to solve the motion. So if we have a look at projectile motion, let's think about one that's launched on an angle. So if we have this projectile, we launch it out on an angle. It's going to follow a parabolic path. But let's look at what happens in the vertical components and the horizontal components. So the blue is the path that this is following, the purple is the horizontal, and the pinky red color is the vertical. So as it continues on its path through the motion, what we notice is horizontally it's stepping out the same size steps as it goes. Vertically it's stepping out smaller and smaller steps each second, to the point that it hits its peak and then begins its path back down, all the while staying with equal horizontal steps until impact at the ground. So that gives you a bit of an idea of what's happening with the projectile and what we're going to be looking at. So solving projectile problems. If we want to solve projectile motion problems, then we're going to use equations that have constant acceleration. Why constant acceleration? If we think back, there was no acceleration that was happening in the horizontal. They were all equal steps. In the vertical plane back there, we saw it slowing down and slowing down and slowing down until the point that it stops at the peak, and then it begins to speed up as it comes back down to the ground. So this is due to gravity. What you always need to be careful of when you're doing projectile problems is your units. That really goes for any motion problem at all. So firstly, let's recall the equations of motion. So there were three key equations that we use. V equals u plus at, so that's final velocity, initial velocity, acceleration and time. We have v squared equals u squared plus 2ax, where x is the horizontal or the vertical displacement depending on which way we're going, and x equals ut plus a half at squared. Using those three equations, you can solve any projectile problem if you have the information, enough information to solve the problem. There are two others, x equals u plus v excuse me, x equals u plus v over t divided by 2, and v average equals u plus v over 2. These are for constant acceleration. But I discourage the use of those because people tend to just start adding the wrong values in and use it in the wrong place. Stick to these three and they can solve every problem that you'll be given. So let's have a look at an example. So we're considering vertical motion only, which is a review of what you did in Unit 2. So we have a ball thrown upwards. It has a velocity of 45 kilometers per hour. So I want you to find peak height, time of flight, velocity after 0.5 seconds, and height when the velocity is negative 3.8 meters per second. Would encourage you to pause this and have a go at solving those for yourself. Be good practice to try and recall it and get that going again in your mind. First things first though, we have a units issue, 45 kilometers per hour. SI units are meters per second. So step one in solving this is firstly we're going to define up as the positive direction. That's usually the default positive direction. And then convert velocity to meters per second. How do we do that? Simplest way is divide by 3.6 to go to meters per second. So 45 over 3.6 is 12.5 meters per second approximately. So that might actually be accurate. So if you want to go from meters per second to kilometers per hour, we just need to multiply by 3.6. Ask me in class if you're not sure how to do this or where the 3.6 comes from, and we can go through that quickly. So if you've had a go at those problems, I'm going to walk through some of the techniques in solving this problem and some of the things to be careful of or look out for. So finding peak height. So basically the easiest thing to do is consider half the motion. You want to know how long it took to get from the ground to its maximum height. First thing to do is list all of your variables. So firstly we know u equals 12.5 meters per second. We know acceleration is negative 10 meters per second squared. Negative because up is positive and gravity is always acting down. Okay, this is always in the vertical plane. We know that the final velocity is 0 meters per second. How do we know that? Basically, when it gets to the peak height, it's no longer travelling up. It's stopped. It's turning around. It's coming back down. So v equals 0 meters per second. And x, well, that's our question mark. If we look at all our variables, we've got v, u, a, and x, then the equation we want to use is v squared equals u squared plus 2ax. So substitute in, we've got 0, 12.5 squared plus 2 times negative 10 times x. Now I will tend to substitute directly in as negative 20 in further problems, but the negative 20 comes from there. So solving that, so adding 20x to the other side, dividing by 20, we get x is approximately 8 meters. So peak height is about 8 meters high. Time of flight. We have two ways to complete this. So the one method basically means find the time that it takes to go from the ground to the peak and then double it because it's going to take the same amount of time to get back. And that's because of the symmetrical nature of it. The second method involves this, and this is my preferred method, and I use that where possible, and that's because it means that you find it all in one step. You don't have to remember to double it, and less chance of making an error. So if we recognize that the impact velocity, the speed that it hits the ground with, is the same as when it leaves, other than it's going in the opposite direction, hence the negative, then it means that we can substitute into v equals u plus at. So we have negative 12.5 v, we have u as the positive 12.5 minus 10t, and solving we get t equal to 2.5 seconds. Okay, find v after 0.5 of a second. List your variables again. We've got u, a, t. We need to know v. Look at that, v, u, at. We've got v equals u plus at. Substitute in 12.5 minus 10 times 0.5. We get 7.5 meters per second. Find x when v equals negative 3.8. List our variables. We have v, u, a, and x. So v squared equals u squared plus 2ax will be the equation that we want to use. So we get negative 3.8 all squared. Put the negative inside brackets so that you don't end up with a negative value out here. Otherwise you're going to end up with the wrong answer. Okay? When you square the negative, it should become positive. And then x equals 7.1 meters. If you had that negative and you added it to this side, what you would find is that you would end up with a height greater than the peak height. And that's a bad thing, clearly. So you need to just ensure that if you get a height greater than the peak height, that you've made an error, and come back and check that. So example 2, we've got a man throwing a stone vertically up, as he did in the previous example, but then it falls down from a cliff, falling 30 meters below to the sea. So find the initial velocity, final velocity, and time of flight. So this time there are a couple of just variations as to how we go about solving this problem. Firstly, initial velocity. So we weren't given the velocity. List your variables again. What do we know? We know the height that it reaches above where he is 20 meters. Acceleration is negative 10 in the vertical direction, so that's a given. At the peak height, v equals 0. So we can use that again, and we're after u. So u, v, a, and x. The equation that we have is v squared equals u squared plus 2ax. So substituting in, we get 0 equals u squared plus negative 20 times 20. The negative 20 is the 2a. Rearranging that, we get u is 20 meters per second up. Final velocity. So this time, because it doesn't land at the same height that it was released from, we've got to go through a different way to calculate this. So the total height, so we're going to start from the peak height, where velocity is 0. The initial velocity is 0 now, which was the final for the first part of the trip. So that's now its starting velocity. It's going to fall past the man at 20 meters, down to the sea at 50 meters below that starting point, hence the negative 50. A is still negative 10, we're after v. So same equation, v squared equals u squared plus 2ax. Substituting in, v squared equals negative 20 times negative 50, or negative 1000. So v, if we take the square root, is 31.6 meters per second down. And time of flight, well, velocity, final velocity, impact velocity is negative 31.6 meters per second. We have the initial velocity is 20 in the positive direction. We have a equal to negative 10. We've got t as our unknown, so we've got v equals u plus at as our equation. So we substitute in and rearrange to solve for t, which is 5.1 seconds. So those are the keys for solving different projectile equations, particularly those that are just in the vertical plane. What we will do next screencast will be to analyze the way to do it when we've got a horizontal component added.